Design and manufacture of lift fan systems is complete. Fan flight worthiness testing has ended and Army approval received. Results generally exceeded specifications in terms of performance and system weight. Design and manufacture of the two airplanes is progressing. Conventional flight simulation has been completed and 6th degree of freedom hover and transition simulation has begun. Ground tests of the aircraft will precede first flight, which is scheduled for December 15, 1963. Fan acceptance tests are performed in the GE Evendale outdoor test stand. Each fan is run steadily for over 2 hours to check mechanical and aerodynamic performance. As of May 15th, 4 lift fans and 2 pitch fans were accepted. Aircraft tailpipe and nozzle were mounted in the test stand and proof tested. Routing and installation were identical to airplane configuration. Bellows allow for movement of the tailpipe due to thermal expansion. Nozzle trim tabs are adjustable to maintain rated engine exhaust gas temperature. The remainder of the lift and pitch fans are undergoing final assembly. A total of 6 lift fans and 3 pitch fans are being built for the XV-5A program. Front frame forward air seals were ground with a tool mounted concentric with the fan bearing. The air seal is of honeycomb material. Inlet vanes were trial assembled. During rotor buildup, blade platforms were installed. These platforms form the flow path at the fan hub. The first flight-rated lift fan delivered to Ryan is being prepared for installation. The XV-5A wing, in spite of the unusual design load transmittal path, compares favorably in weight with conventional wings. Number 1 fuselage has been removed from the assembly jig and moved to its mating jig. Forward jig mounts are adjustable in all directions to permit exact alignment of the aft section. A space frame containing the propulsion system midsection will join forward and aft fuselage. A manufacturing template was trial fitted prior to installation of the stressed acrylic windshield, avoiding wear and abrasion on the flight quality component. The vertical stabilizer contains the fuel vent, hydraulic lines, and electrical leads. The rudder assembly is a 2-hinge conventional design without power boost. Framework shows cutout for the trim tab. The rudder pedals incorporate toe brakes operating individually. The pedals are adjustable fore and aft for pilot comfort. The horizontal stabilizer, constructed of magnesium alloy over aluminum ribs, will be attached to the top of the airplane fin and is all movable. It will be programmed in VTOL flight and will travel a total of 25 degrees. It is also pilot adjustable. Landing gear doors are stressed to resist torsional loads with the airplane flying forward at speeds up to 180 knots. The space frame is fabricated of high-strength Mar-aged steel. Tensile strength is in excess of 200,000 pounds per square inch. The aft main fuel tank is formed of aluminum and has a rubberized interior. The tank has a capacity of 810 pounds of JP4 fuel. The airplane canopy was subjected to extensive load tests. Hydraulically actuated load pads exert pressure on the test canopy. Loads were repeatedly applied and relaxed to measure plastic deformation. Designed for a load factor of 4 and an ultimate of 6, the canopy performed exactly as designed. The canopy ruptured at predicted load conditions. In another component test, a lift fan door was checked for deflection. Test duplicated conditions expected to exist with the airplane in forward flight and fan doors closed. Forces tending to open the door were applied with sandbags. Deflection somewhat exceeded design specifications. Redesign and alterations have overcome this problem. Pressure and force tests of a tandem piston, dual hydraulic actuator were performed in the Ryan Hydraulics Laboratory. Cooling blowers that will be driven by the two J-85 turbojets were installed on the hydraulic electrical simulator as part of tests of the complete power system. The horizontal stabilizer actuation mechanism is mounted on the simulator's tail section. The mechanical mixer box is being assembled using anti-friction bearings designed for minimum backlash. Near the end of this reporting period, both airplane aft sections were in the mating jigs, preparatory to final assembly. And the pitch fan and inlet were trial assembled on number 1 airframe. Although not part of the XV-5A flight research aircraft contract, free flight tests of an 18% scale model of the airplane were conducted by the National Aeronautics and Space Administration, Langley Field, Virginia. The model has 3 tip turbine fans powered by high-pressure air. Exit louvers and pitch fan thrust modulating doors are controllable in flight to introduce vectoring and pitch fan trim. Fan-modulated control was not used in initial flights. Reaction jets on wing tips and tail control attitude in this initial series of tests. Here, the model is hovering out of ground effect in controlled flight. Wind tunnel speed is 0. Motions of model are greatly exaggerated due to scale effect and are more rapid than that of a full-scale XV-5A. This flight indicates the ability to recover from deliberately induced pitch. Yellow tail flag shows introduction of pitch and recovery action. The model takes off vertically. Controllability in roll is demonstrated with increased roll moment of inertia. 1 pound weights were forward flight with wind tunnel speed at 23 knots. Forward transition flight at wind tunnel speed of 87 knots. Test data indicated that the XV-5A should perform satisfactory transition from hover to maximum fan-supported flight speed without objectionable handling characteristics. During the next reporting period, progress of the XV-5A flight research program will include rollout of number 1 airplane to begin static performance tests and vibration and resonance checks of number 2 airplane.